Hey, hi, good evening, everyone. I hope everyone is doing well. Yes, let's get started, guys. So, what did we discuss yesterday? Yesterday, we have started with Numpy module, right? So, yesterday, we just understood how can we create uh, arrays using it might be one-dimensional array, two-dimensional array, or three-dimensional array, or n-dimensional array using different functions present in Numpy module. Right, so we'll continue the session, but before that we'll quickly recap what we have understood yesterday. Right, so Numpy, which actually is no, it stands for numerical Python. Let me increase it in size. Yep, so Numpy stands for numerical Python, and it was developed both in C and program Python languages. And this is a module. Numpy is a module. What is a module? Module is nothing but it's a collection of variables, functions, and classes, right? So in order to use the functions, or in order to access the functions present in a module, we have to install the module first, right? So yesterday one of our friend have commented for the respective video, and we have provided the answer. So my friend, you are trying to use a command in IDLE, which is not possible, right? So the commands like pip install module name, this command should be executed in command prompt. Or if you have, installed Anaconda, you have to use Anaconda prompt, right? So you cannot use these prompts, use these commands in IDLE. So that's not the right thing. I have provided you the answer. Just go through it. Right. So first of all, we should have the NumPy module available in our machine, in our system. Right. So how can we install this NumPy module? Using the command pip install module name. What is the module name here? It is NumPy. And is NumPy lower is in lowercase or uppercase or in proper case? How can we understand the right version of it? You we have to visit a repository called PyPy. The good practice will be getting this command from pypy.org repository. So whatever the modules or libraries that you're going to use in future, okay, always visit pypy.org, get the command, copy it from the repository, and then install it. Right. So post installing the module, we have to import the module. Import NumPy. Vayakil, what is the use of importing the module? It's nothing but when you import the module, only then you can access the functions or variables or classes, whatever it might be. Whatever is present inside the module, only after importing it to the sessions memory, we can access the required thing present in it. Okay, so if you are familiar with programming languages, there is a concept called arrays, right? In order to create arrays in Python, the only possible way is using NumPy module, because it's not an inbuilt data type present in Python. Whereas if you go to other programming languages, arrays are inbuilt, right? So using NumPy module, we are going to create array objects, arrays, right? So we have to install NumPy, then import NumPy module. After importing NumPy, there are many functions present in NumPy, and using these functions, we can, you know, create array objects. So what are the different functions that we have used yesterday in order to create the arrays? ND arrays, in order to create ND arrays, n dimensional arrays. What are the different functions that we have understood yesterday? Come on, friends. Keep it out the chat. The first and the foremost important one is array function. Am I right? Array function. Yes. So array function, as it is coming from NumPy, you know, you have to keep it as np dot or numpy dot array. What is np? Np is nothing but an universal standard alias name given to NumPy. Okay. Then next to array, what else did we discuss? I think we also discussed np dot arrange. Np dot arrange. Then what else? Np dot zeros, np dot ones, np dot full. So, and finally np dot identity. These are the different functions that we have understood yesterday for creating ND arrays, right? So using an array function, what is the purpose of array function in NumPy module? Array function is used to convert any traditional Python object into array. Okay, you take any traditional Python object, like take list, tuple. Okay, so these objects will be converted to arrays, and we can create one dimensional object, two dimensional object, three dimensional, n dimensional objects also can be created using array function present in NumPy. Okay, then next function that we have discussed is arrange, which is part of NumPy, but the syntax is again similar to range function that we have discussed as part of inbuilt functions, where the syntax is a range of start comma stop comma step size. Okay, start comma stop comma step size. By default, start takes 0, step takes 1, and stop follows the rule of n minus 1. Right? So, but the limitation with arrange function is arrange function creates only 1D arrays. We cannot create 2D arrays or multi-dimensional arrays using arrange function present in NumPy. Then if you have a question of creating multi-dimensional arrays, we use reshape function. Okay, on the output, if you try to use reshape function, this will reshape as per the requirement, and it creates a multi-dimensional array. Right. Then zeros function. Zeros function present in NumPy is used for building a zeros matrix, zeros array. So we can create one dimensional array, one dimensional zeros array, two dimensional zeros arrays, three dimensional zeros arrays, so on. Okay. Then np dot ones. np dot ones function is used for building a ones matrix. So like how it's creating a zeros matrix over here, we can create a ones array or ones matrix. So again, one dimensional, two dimensional, or n dimensional arrays can be created using ones function. Then np dot full. np dot full function, especially full function present in NumPy array, is used for filling the entire array with a particular element. Okay, whatever the value that we are going to specify inside the full function, with the specified value, it fills the complete array. We can create one dimensional, two dimensional, or n dimensional objects using full function. And finally, identity function. Identity function is used to build an identity matrix. So where identity or unit matrix represent a square matrix where the diagonal elements are 1 and non-diagonal elements are 0. So these kind of matrix can be created, nothing but arrays can be created using identity function present in NumPy. Right. So all of these were being discussed, and we have our yesterday our class is completely based on creating array objects. Right. So yesterday we are just creating the objects, but as we discussed, arrays are mutable. That means arrays object can be changed even after creating. Then arrays support indexing. But did we work on indexing yesterday? No. Right. Arrays also support slicing. As they are indexed, we can also come with slicing topics, slicing concepts. Okay, so today we are going to understand indexing, slicing, and additionally, arithmetic operators on arrays. Okay, so all these we are going to discuss, and let us continue, guys. Right. So all these were being discussed yesterday. Zeros, ones, full identity. Yep. So till here it was covered, and we are supposed to start basic indexing on arrays. Okay. Why it is mentioned as basic indexing, I'll tell you guys, because we are clear on indexing. Right? Indexing is nothing but assigning a value for each and every element present in the object. Right? If I want to access a single element, I can do it using indexing. Are list indexed or unindexed? Use the chart. Are list indexed? Come on, guys. Are list indexed or not? Yes. List are indexed. What about tuples? Are tuples indexed? No. Tuples are not indexed. Right? They does not follow the top concept of indexing. Tuples are also indexed, guys. What makes the difference between list and tuple? Majority of them say no. Are list indexed? Yes. Are tuples indexed? Yes. The only difference that makes between list and tuple is mutability. Lists are mutable, tuples are immutable. Don't get confused. I see majority of the answers as no. Tuples are also indexed. Can't we access the single value in tuples? Yes, we can access the single values. Okay. Then, are sets indexed? These are very important. Are sets indexed? No, sets are not indexed. Because they are unindexed, they are unordered. And it does not allow duplicates because they are unindexed. If there is indexing, obviously it should allow duplicates. But in set, you cannot have duplicates because they are unindexed. Right? Are dictionaries indexed? Answer. Everyone have to answer. Don't sit idle. Okay. Are dictionaries indexed? No. Oh my god. key and value are used for accessing the data. Okay. See, in dictionary, we have keys and values, right? Keys are unindexed, whereas values are indexed via keys. That should be your answer. Okay. See, you cannot tell no because in dictionary we have two elements. I mean, it's a key value collection, right? Keys are unindexed. We cannot access keys, but we can access values using keys, right? So it should be very clear, guys. Then, are strings indexed? Are strings indexed? Yes or no? Strings are indexed. Don't say no. Strings are indexed. Right. In the same way, arrays also support indexing. But it has two types of indexing. One is the basic indexing that we have understood so far, but there is something called as advanced indexing. Okay. So today's session will be very interesting, and I want all of you to you know interact throughout the session. you know right. So let us continue with our day for the topic indexing. Indexing is nothing but accessing single element from the arrays. Since numpy create, using numpy module we just create only arrays. Okay. Arrays support indexing. What is the syntax? It is similar again. Array within the square braces, pass the index. This is for one dimensional array. Oh my god, that means will it change for two dimensional, three dimensional? Yes. Hold on. Let us start with one dimensional. So I'm importing numpy as np. Import and as are two keywords. Numpy is our module which we have installed, and I'm importing into the memory. Okay, so that I can access all the functions, classes, variables, whatever is present inside numpy. I can use using the dot notation. Np dot the function or np dot anything else, whatever is present inside numpy, you can access it. For that you have to import. Importing was done. Now I'm going to create an array. It's a one dimensional array, and I'm storing in variable a. A is an array of size 6. There are in total 6 elements, 6 values, and out of that we have minimum as 10, maximum as 60. Right. Let me print this a to the console. I'm just giving a. So this is my array. Right. Then a of 0. By default, in Python, indexing starts from 0. But in which direction? In left to right direction. 0, 1, 2, 3, 4, 5. Okay. So a of 0 will give us 10 as the output. Right. What will be the output for a of 3? A of 3, 40. Right. A of -1. Okay. Again, go back to the indexing concept. Index value can be either positive or negative. When index value is negative, when you go in the reverse order from right to left, -1, it starts at -1, not 0. Okay. -2, -3, -4, -5, -6. So what are we going to get the output over here? It will be 60. A of -1, 60. A of -5, 20. Okay, I hope it's clear because this is what we have understood so far with respect to strings, list, tuple, other objects as well. Right? So the same concept. Clear. Let me execute. So this should return as 10, then followed by 40, then 60, okay, and finally 20. Clear? Now let me use the same indexing concept on 2D arrays. Let me use the same concept on 2D arrays. I'm creating a one-dimensional array and I'm storing in A. A is a one-dimensional array of size 6. Okay, but using reshape function, I'm going to convert one-dimensional array object to two-dimensional array object. Okay, so this one-dimensional array object will be converted to two-dimensional array object. Fine. What is the size of this two-dimensional array object? 2 comma 3. That means we'll have 2 rows and 3 columns. Okay, so 2 rows and 3 columns. What will be the B array? What will be the output for B? B will be nothing but 10, 20, 30, and I'm not supposed to keep comma. In arrays you'll not have comma like list, whereas in list you'll have comma. This will be your B array, a two-dimensional array where it will have 2 rows. Rows are 2 and 3 columns. Right? 10, 20, 30, 40, 50, 60. Then what makes, again, if someone was asking the question, what makes the difference between list and array? Both of them will be, all the elements of list and array will be inside a square brackets, but list elements will be comma separated, whereas array elements will be space separated. Okay, it does not have any commas, guys. Don't get confused. Right? So let me execute this and print B. Reshape is done and B is this one. Don't assume, Akhil, why it is again showing comma over here. Okay, it's not showing comma. Actually, if you print it, you'll get the right array. Use print function to understand the array properly. Now it will make sense. See, this is the array that we are actually working on, the two-dimensional array. 2 rows, 3 columns. As I told, as we discussed, an array elements will be space separated. Okay, whereas a list elements will be comma separated. Okay, right. Now comes the question. How can we access the values, a single value present in two-dimensional array? Here is the syntax. The syntax is array of row index comma column index. What is your row index? Then column index. If it is a one-dimensional array, you need to pass only one value, similar to list. But if it is a two-dimensional array, since we have rows and columns, we have to pass two values. One is for rows and the next one is for columns. B of 0 comma 0. What will be the output? Simple. Don't get confused. So this is index row number 1, index 0, row number 2, index 1. In the same way, column number 1, index 0, column number 2, index 1, column number 3, index 2. Right? So row index is 0. So that means this row. And column index is also 0. That means this column. So the output will be 10. Good. It's not 40. It will be 10. Pay attention. The output will be 10. Can I get what will be the output for line number 210? B of 0 comma 1. B of 0 comma 1. 0 again, it's representing row 1 and 1 is representing column 2. So it has to be 20. Good, guys. Good. Then what will be the output for B of 1 comma 2? What is 1 representing? Row 2. What is 2 representing? Column 3. So the output will be 60. Good. So let me execute. Our output should be 10, 20, 60. If you understand the syntax, you can literally play in Python. Okay. 10, then followed by 20, then the final one will be 60. Clear? Good going, guys. So we have understood indexing for one dimensional and indexing for two dimensional. Let us also understand the concept of indexing for three dimensional. So since it is a three dimensional object, a third number will be added. Okay. So let us understand the syntax first. Array of index of matrix. Okay. So for the matrix, since we have three dimensions for a three-dimensional array, the first member will represent index of matrix. Again, second index represents row index. Third represents column index. So column and row are as it is. Additionally, we have index of matrix. Right. Let me create a one-dimensional array and store it in A. Done. This one-dimensional array I am converting into a three-dimensional array object. 2, 2, 2. Okay. So what will be the B matrix? B matrix will be a three-dimensional array, and the output will be like it will contain two matrices, because the first number is representing index of matrices. So the B will contain two matrices. In the two matrices, each matrix will have two rows and two columns. So that means, in short, I'll keep it over here. B will be like, the first matrix will be 10, 20. Okay. Then 30, 40. Sorry. 30, 40. So this is one matrix, guys. In the same way, it will also open the second matrix. 50, 60. 70, 80. So this is the second matrix. Okay. And overall, this is your overall array. So matrix 1, matrix 2. In matrix 1, how many rows I have? 2 rows. In matrix 2, how many rows I have? 2 rows. In matrix 1, how many columns I have? 2 columns. In matrix 2, how many columns I have? 2 columns. So that is what this is telling. 2, 2, 2. Right. So let me execute. Let me print B. So this is nothing but the three-dimensional array. Now comes the indexing part. How can we index the values from a three-dimensional array? B of 0, 0, 0. B of 0, 0, 0. The first one represents the matrix index. So this is first matrix where the index will be 0. Matrix 1. M1 is nothing but matrix 1. And in bracket, I am representing the index. M2, index 1. Then the second one is representing row index. Okay. So this is R1, R2, R1, R2. And I'll also keep the index over here 0, 1, 0, 1. Right. This is C1, C2, 0, 1. C1, C2, 0, 1. Now, let us understand 0, 0, 0. So, in the 0th index of matrix, that is representing M1, then 0th index of row, that is representing row 1, 0th index of column which is representing C1. The output will be 10. Good guys. The output will be 10. In the same way, can you tell me the output for line number 220? I'll just give a 5 seconds time. Try to give me the output for line number 220. -1, comma 0, comma 0. Okay. Okay. Hmm. Uh, Not 70. Good, good, good. Right. The output will be 50, guys. How come it will be 50? -1. That means we are going in the reverse direction. If I go in the reverse direction, the second matrix will take -1 and the first matrix will take -2. So -1 of -1 comma 0 comma 0 0 comma 0. The output will be 50. 50. That's what. See, if I go in the reverse direction, the second matrix take -1. Like how we go in the reverse directional list, the index value becomes minus, right? -1, -2, -3. In the same way, this -1 is representing index of matrix. So M2 will take, you know, M2 will take -1 index, and 0 represents index of row 1. Yes. And another 0 represents index of column. So this will be 50. Try out for line number 221. What will be the output for 221? 20 is not the answer, guys. Okay. Okay. 30 is not the answer. 80 is not the answer. Understand. Understand. How come it will be 80? Understand. -2, which takes nothing but matrix 1. Okay. Then 1, which is representing the row index. Okay. So it is row 2, which is this row. Then again, column index is also 1. So column index is 1. So that is nothing but 40. So this should be 40. Not 60, not 10. Okay. So the output will be 40. Pay attention. Focus. The syntax for a three-dimensional array will be array of matrix index, comma, row index, comma, column index. Right? So let me execute. The first one should return as 10. The second one, should return as 50. And the last, indexing should return as 40. Good going. Good, good. So this marks the end of indexing. So I hope it's clear. You can perform indexing on one-dimensional, two-dimensional, three-dimensional, or n-dimensional arrays. Whatever the array might be, we can perform indexing. Right. Now, let me jump into the topic of slicing. Akhil, what is this topic of slicing? Guys, I hope you remember slicing. Slicing, we started discussing from strings. What is this slicing? Slicing is nothing but in order to access multiple values from the object. Okay, instead of accessing a single value, if you try to access a single value, it will be indexing. If you try to access multiple values or multiple elements from the object, it will be slicing. And the syntax will be start, colon, stop, colon, step. Right? The same syntax, but slightly varies depending on the array objects. For one-dimensional array, it is again the same. So one-dimensional array objects are again you treated as list, tuple. They are also one dimensional, right? So one dimensional syntaxes are very easy to remember because we got habituated of using list and tuple, whatever it might be, right? So let me initially start working on slicing for one dimensional arrays. I am creating a one dimensional array using np.array function, and I'm storing in a variable a, and in total I have 7 elements, and 10 and 70 are the minimum and maximum values respectively. Done. So this a I'm printing it to the console. So this is my array which is present in the memory. Now I'm trying to perform slicing on array a. Okay, on the array I'm trying to perform slicing. So the slicing concept says, the syntax says start comma stop comma step. Did I mention in start and stop? No, right? So by default it takes from starting till the end. But what does -1 indicate? -1 indicates in the reverse direction. Print everything but in the reverse direction, right? So the output will be 70, 60, 50, 40, 30, 20 and 10. Okay, so you see, not 70 like that, guys. So this is not indexing, this is slicing. The difference you have to observe. Am I using colon here? Am I using colon? So this cannot be index slicing, and this is slicing. In slicing we'll generally use colon, which is actual syntax. Start comma stop comma step. Okay, start colon stop colon step. What does this mean? A of colon colon. What does that mean? It means to get the array as it is in the same direction from the starting till the ending. You print everything as it is. See, 10, 20, 30, 40, 50, 60, 70. The only difference between line number 28 and 29 is direction. Since I am specifying as -1, it changes the direction from right to left. And for 229, it will not change the direction. By default, it takes the step as 1. So it takes from left to right. Clear? Now let us work on two-dimensional arrays. Perform slicing on two-dimensional arrays. Right. Clear. Let me create a two-dimensional object A. So this is a two-dimensional object of size 2, 3, 2 rows and 3 columns. 2 rows, 3 columns. 2, 3. Right? So what will be the output for line number 238, guys? A of 0, 0. A of 0, 0. The output will be 10 because this is 0, this is 1, this is 0, this is 1, this is 2, 0, 0. Output will be 10. Right. Yes, 10. This, this style of syntax represent indexing or slicing. Is it indexing or slicing? Yes, it is 10. The output is 10. This is indexing. Don't get confused. Why? As we are just using, are we using the syntax of slicing? Am I using colon in between these values? No. So As an example, in order to understand the difference between indexing and slicing, I have kept this, example here. This is indexing and these three belong to slicing, because slicing takes the syntax start colon, stop colon, step. Right. Now let us understand slicing from here. 0 colon. That means the row index is 0. So this row. Okay. So 0 colon represents from 0 you have to print till the last. So from here, go till the last. But what does column says? 0 colon 1. So 0 colon 1 will return as only 0. Start at 0 and stop at 0. So that means only this column, 0th column. So the rows can take from 0 to till the last, but column takes only 0th column. The output will be 10, 40. Understood? From here, the actual concept begins, guys. Pay attention. 0 index says, it's representing row index. What is the 0 colon represents? What does 0 colon means? 0 colon means start at 0, then go till end. Okay, so 0 comma 1. I can go 0, next to that I have 1. So row 1 represents of 0 is 10, row 2 of which is 1 is 40. Okay, so 10 comma 40 will be given. Then let us come to column. With respect to column, it should start at 0 and end at 1, which is nothing but 0. Which is nothing but 0. Okay, so the 0th column has 0 comma 10 comma 40. So the output will be 10 comma 40. In the same way, will you try it for line number 240? 0 colon comma 1 colon 2. 0 colon comma 1 colon 2. So again, this is representing row index. 0 colon means 0, then 1. Start at 0. Obviously, go till the last. How many rows I have? Only 2 rows. 0 row and 1 row. Okay. Then, with respect to columns, it says start at 1 and end at also 1, because the stop value is 2 and stop by default follows n minus 1. 2 minus 1 is 1. So it stops at 1. Nothing but column 2. So for this the output will be 20 comma 50. I hope it's making sense. Pay attention, guys. Just give a try for line number 241. 1 colon comma colon. What will be the output for 1 colon comma colon? Meanwhile, I'll try to execute these lines. This is 10. The next one will be 10 comma 40, because print all the rows from 0 but take only the first column, that is 10 comma 40. And in the same way, print all rows but take only the second column, 20 comma 50. What will be the output for line number 241? Why no one is giving the answers in the chat? Try it, guys. 1 colon. 1 colon is representing row index. Start at 1 and how many rows we have? 2 rows I have. Okay. 2 rows. We have 2 rows. Row 0, row 1. Right. Start at row 1. So if I start at row 1, anyhow I have only 1 row. So that means this row. Then you print all the columns. This column represents all the columns. I did not specify start, I did not specify stop, I did not specify step. By default, the entire, all the columns should be given as output. The output will be 40, 50, 60. Simple. If you understand the syntax, you can play. But if you don't understand the syntax, you'll not understand anything. Right? So I hope it is making sense. Now let me jump into 3D arrays, slicing on 3D arrays. Okay, so here is a 3D array that I'm creating and assigning to LST. Okay, sorry, this is a nested list, my bad. I'm creating a nested list and I'm converting this nested list into an array using array function from Numpy and storing in array2, ARR2. This is an three-dimensional array. Akhil, on what basis do you tell this is a three-dimensional array? Simple. See, I see rows and columns. Okay. Then apart from rows and columns, I also see matrices. Matrix 1, matrix 2. So if matrices are present, it is representing 3 dimension, right? Matrix represent 1 dimension. Then rows represent the second dimension, columns represent the third dimension. So it is 3-dimensional array that we have created. Now let me work on indexing. Sorry, slicing. Slicing on 3-dimensional array. Colon, 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 comma, 0, colon, 1. What will be the output here? The first colon represents about matrix index. Okay, the second column represents for rows. Third column represents for columns. So this comma is separating between them. You bring or take the output for all the matrices. Then with respect to rows, again all the rows. But with respect to columns, it is 0, colon, 1. 0, colon, 1 will be 0. Why? Start at 0, end at 1. Nothing but start at 0, end at 0. Right? So this will represent column 1 of each matrix. So the output will be 1, 4, 7, 13, 16, 19. I hope it's clear. Might be, you guys were struggling to understand, but if you, do hands-on, then probably you'll understand more. Right. Now comes the next example, colon, comma. That means take all the rows, I mean both the matrices, all the matrices. Then with respect to rows, 0, colon, 2, which is nothing but row 0, index 0, and index 1. That is this row and this row of matrix 1, and this row and this row of matrix 2. Right. With respect to columns, 1, colon, 3, which is nothing but column 1, column 2. So this column and this column, and this column of matrix 2 and this column of matrix 2. Right? So the output will be, what will be the output, guys? 2, 3, 5, 6, 14, 15, 17, 18. See, try to understand. Right. Let us focus on line number 256. What will be the output for line number 256? Again the same output. Colon, comma, which is representing matrices. Colon 2, which is representing rows, and 1 colon. So this will represent 0 and 1 row of indexes, and this is representing column indexes for column 1 and column 2. The output will be again same, 2, 3, 5, 6 from matrix 1 and 14, 15, 17, 18 from matrix 2. Again the same. Okay, so do a number of examples with respect to slicing, because indexing it's very easy, but for slicing you do many examples. Okay, and try to understand the syntaxes first of all. Right, now let us go and understand the advanced indexing topic. What is this advanced indexing topic? Advanced indexing is again if you want to access multiple elements, but if there is no certain condition, okay, there is no certain condition, but you want to access multiple values. Slicing is also accessing multiple values, right? But here there is no condition, okay, but still you can access multiple values. That is nothing but using advanced indexing. Okay, how can we achieve it is, let us work on one dimensional array easily. The easy example that we have, I am taking a one dimensional let us work on one dimensional array first. I'm taking a list and I'm converting into an array, and this is a one dimensional array. Sorry. Yep, sorry guys. Instead of using it clicking on the execute button, I have you know executed the debug button. So yep, let me take this. Slicing is done. Yep. So creating a list, then converting this list into array. So this is what we have understood so far. Now, if I want to access, you know, elements that are present at 0th index, index 2, and index 7, okay, is that possible at a single time? Yes. In general, yes, it is possible. First, I'll access using array of 0, it will return me 10. Array of 2, it will return me 30. Array of 7, it will return me 80. But the thing is, I don't want to access at 3 different times. In a single time, I have to get all these values. Is that possible? Yes, it is possible. It is possible using advanced indexing in Numpy. Only for arrays it is possible, guys. So that is the reason we'll understand how it is possible. What I'm doing is I'm storing the required indexes, whatever the values that I want to achieve. I'll try to understand those indexes first and storing them into a list. Okay, so the syntax is nothing but array of the list of indices that we have stored. If you execute it, it will give us the output 10 comma 30 comma 80 as an array, because you are accessing from an array object, right? The output will all obviously be an array. In the same way, can I access the elements of 1 2 7 0 0 2? Yes, you can access any value without any certain condition. If there is no condition, but if you want to access multiple values at a single time, it is possible using advanced indexing. So I'm storing in a list and using this list a of ind, which is the list, it will return me all the values. Right. So this is very easy with respect to one dimensional objects. But what happens if you work on two dimensional objects? Again, it is same. I'm creating a two dimensional array and I'm storing in mat. So this is a two dimensional array of size 4 by 4. And what if I want to access these elements, principal diagonal elements 1, 16, 11, 16, 1, 6, 11, 16. These are the principal diagonal elements, right? Can I access such kind of elements? Yes. How come, Akhil? It's very simple again. That's what. The syntax is array of whatever the array object that we are working on, array object of, first give all the row indexes, comma, then the column indexes. So 0 comma 0, which is nothing but 1. Then 1 comma 1, it is 6. 2 comma 2, it is 11. 3 comma 3, it is 16. See, but did I use slicing? No, right? This is not slicing, guys. Don't get confused. This is not slicing. Slicing syntax is completely different. Start colon, stop colon, step size. Am I using any colons? Am I using any start, stop, step? No. These are just representing the indexes. Okay. Now, in the same way, can you tell me what will be the output for line number 287? 287. Mat of the array object of 1 comma 3 comma 1 comma 1. What will be the output? Just give a try. 1 comma 1 is nothing but it will be 6. See, row 1 index column 1, so it will be 6. 3 comma 1 will be 3 comma 1, it will be 14, right? So alphabetically this comes first, right? So the output will be 6 comma 14 array, right? So in this way you can access any number of elements, okay, without any specific condition by just passing their indexes. Yeah, basic indexing is nothing but accessing only one element from the array or from the object, but using advanced indexing you can access n number of elements, n number of values from the arrays. In the same way, I'll do it on n dimension, the 3-dimensional array. I'm creating a list, nested list, and I'm converting this nested list to array, and I'm printing that mat 3D array. So this is a nested list of size 2 comma 4 comma 4. How it is 2 comma 4 comma 4? Two matrices, so 2, then 4, sorry, 3 rows it is, so it is 3, then 4 columns it is 4. 2 comma 3 comma 4. So for better understanding, mat 3D, yep, here it is 2 comma 3 comma 4. Right, now I want to access elements like 1, 14 and 24 from the 3-dimensional object. Where do we have 1? 1 is present in the first matrix, in the first row, in the first column. So 0 comma 0 comma 0, 0 comma 0 comma 0. Okay, 14 is present in the second matrix, so it will be 1, and index should be 0, column should be 1. In the same way, 24 is present in matrix 2, which is taking index 1, and row will be third row, index will be 2, column is fourth column, index is 3. So the output will be 1 comma 14 comma 24. Right, one more example. What if I want to access 10 comma 16 but using negative indexing? Yes, in the same way I'll go in the reverse direction. Okay, so from reverse direction, -2 represents the second the first matrix, -2 comma -1. So in the second matrix, what is the -1 row? So the last row, and -3 column. So -3 column will be 10, right? So -2, -1, -3. Then in the same way, -1, this one, okay, this is going to take 10, and this from this we'll get 16. So the output will be array of 10 comma 16. The same concept, but we are doing it using negative indexing. The concept is same, guys, don't get confused. Done. So this marks the end of indexing. From here onwards, we have arithmetic operations. So what are the different arithmetic operators that we have used as part of operators topic? What did we learn? Make it fast. Use chat, and I want your reply. What did we learn as part of arithmetic operators? Addition, subtraction, multiplication, division, then floor division, modulus, and power, exponential, right? So when you try to perform addition operator, when you perform addition between two lists, what happens? Can someone tell me what happens when you try to add two lists using addition operator? Now we'll understand whether we are practicing or not. If you do hands-on, for sure you'll answer, because these topics we are covering on daily basis. When you try to add two list, 1 comma 2 plus 1 comma 2, what will be the output? 1 comma 2 plus 1 comma 2. When you add two lists using addition operator, it will perform concatenation. Okay, don't assume that the values will be added. The output will not be 2 comma 4. The output will be 1 2 1 2, right? So this is with respect to list. But are we working on list? We are taking list, but we are converting the list into arrays. So this holds arithmetic operations on arrays. Now you'll understand the difference between list and array. Right. Let me take two nested lists and store it in L1 and L2 respectively. L1 I'm converting into an array object and storing in A, printing A. It's a two-dimensional object that I have, 2 comma 2. In the same way, converting L2 into array and storing in B, it's a two-dimensional object, again 2 comma 2. Let me print it. So this is the two-dimensional object. Now let me perform addition operator. Before I perform addition operator, in Numpy there is a function called add, which performs addition. Okay, so which performs addition? Np dot add of a comma b. A is an array of 2 dimension and b is an array of 2 dimension. What might be the output? So this is A and this is B. What might be the output? It does not perform concatenation. The values get added here. It will be 10 plus 1, 11, 20 plus 2, 22, 30 plus 3, 33, 40 plus 4, 44. So I'm storing in C, right? So I'm storing in C, I'm printing C. That makes the difference between list and array. If you try to add to list, it performs concatenation, whereas if you try to add to arrays, the values get added. So instead of using add function from Numpy, let me do one thing. Let me use arithmetic addition operator and see the output. The output will be same again. Even this and this both are same, right? In the same way, let me perform subtract. Excuse me. Np dot subtract a comma b. From a you are subtracting b, so 10 minus 1 9, 20 minus 2 18, 30 minus 3 27, 40 minus 4 36, right? I'm storing all these values in C and printing C to the console. Actually, can I also use arithmetic subtraction operator? Yes. You either use the function that are present in NumPy or the operator. Okay, the output will be same. These are arrays, not list. The output will be same. Okay. What if I use multiplicative operator on list? When you try to multiply a value to a list, it performs multiplication? No, it performs repetition. List of 1 comma 2 into say 2. The output will be 1 2 1 2 again. Repetition happens. But on arrays, the multiplication happens. Np dot multiply of a comma b. You are multiplying a with b. So 10 into 1, 10. 20 into 2, 40. 30 into 3, 90. 40 into 4, 160. So let me execute. Let me show you the output. See. I'll do the same. I'll achieve the same using multiplication operator. The output will be same. Either using the function or the operator, the output will be same. All right. So this is an additional, function that we are going to discuss. I hope every one of you remember matrix multiplication. So in matrices, we have a topic called multiplication, right? So the same thing can be done in on numpy arrays. Okay, using dot function or matmul function, matrix multiplication. Okay, np dot function, which is representing matrix function, and it multiplies a with b and stores in C. So the multiplication that was done so far and this multiplication, both are different ways. Both are not same. This is matrix multiplication. Okay, let me also perform matmul, nothing but matrix multiplication using matmul function. The output should be same, right? So these outputs are same. Either use dot function or matmul function from NumPy. It performs matrix multiplication. Then next to that we have divide function, which is used to perform division with respect to arrays. This is also present in NumPy. Np dot divide of a comma b. Okay, so when it performs division, it is dividing a by b, and these are your output: 10 by 1, 20 by 2, 30 by 3, 40 by 4. And by default, divide function also returns float values, right? I'll get the same output even if I go with the division operator. See, right? Then next to divide operator, we have the division operator. We have floor division function. So floor division, there is a separate function present in NumPy, which is used to work on similar to floor division operator on arrays. Okay, all these functions present in NumPy, they work only on arrays. Right. I'm performing floor division with respect to A on A with respect to B, and I'm storing in C. So all the output will be 10. That's it, right? And instead of floor divide function, let me use floor division operator, double backslash. 10 comma 10 comma 10 comma 10. Why am I not explaining? Because all these things we have discussed in operators, right? Now in operators we have took integers. Here I am taking arrays. That is the only difference, guys. Okay, if you understand the operators properly, you need not worry. Then comes the modulus function, np.mod, which performs modulus. Similar to modulus operator, it returns remainder. So in this case, it should return zeros, because all of them will return only zero as the remainder. 10 by 1, 20 by 2, 30 by 3, 40 by 4. In each and every case, it is dividing properly, exactly, and the remainder will be zero. Instead of using mod function, I'll try with modulus operator percentage. Still the output will be same. There is no, change with respect to the output. Either you do with the function or the operator, the output will be same. Right. Now the last power function, okay, which performs similar to the exponential. For that, I'm defining two lists. First of all, the nested list L1, L2, and converting these L1, L2 to arrays A, B. Okay, done. Both of them are two-dimensional arrays, and I'm using power function coming from Numpy, which performs exponential power 10 to the power 1, 20 to the power 2, 30 to the power 3, 40 to the power 4. So 10 power 1, 10, 20 power 2, it is 20 into 20, right? 400. 30 power 3, 30 into 30 into 30. So it will be around 27,000 probably. 40 into 40 into 40 into 40. 40 repeated for 4 times, around 256. So 256 4 zeros. So the output is in this way, right? So still I can get the same output using double asterisk mark, which represents exponential. The output is same, right? So this marks the end of NumPy module. And if you are generally, if you want to be proficient with respect to modules, the first and the fundamental modules that we have to cover is NumPy, Pandas, and Matplotlib. For any person, in order to get a job, in general, they'll ask you whether you are good in NumPy and Pandas and Matplotlib libraries modules. If you say yes, yes, obviously they'll ask you some questions, and you know you can rock the interview. But what if you say no? The chances of getting hired will be less. So NumPy is a very important module, guys. You know, here whatever we have learned is just a part of it. But when you try to do more examples, when you try to take more examples on each and every topic, then you'll grab more hands-on experience. When you have more hands-on experience, since you have more exposure, you'll answer every question that will be asked in interviews. Ultimately, our aim is to get a job, right? So I'll stop the day here, and we'll continue in the next session with respect to you know pandas. The next module that we have is pandas. If you have any kind of questions, please respond. Technical questions. If you have any kind of technical questions, uh, guys, better take running notes. If not, do one thing, at least do hands on, post the session with respect to your each and every topic that we are doing. Do hands on, right? If you have any questions, yes, it's time to ask your technical questions. If you don't have any kind of technical questions, you know so as we have completed NumPy, the last topic that was pending with respect to Python is pandas. Probably we'll be completing pandas on the next day, on say Monday. And I request all of you to do hands-on. Okay. In advanced indexing of 1D array, you mentioned same variable twice. Uh, Advanced indexing. 1 minute. Okay. Slicing advanced, yes, of 1D arrays. You mentioned same variable twice, but the output is correct. I did not mention twice, right? Where did I mention twice? I have created the array first, then whatever the values that I'm going to access, all the values, the index of those values, I'm storing those indexes in a list, and I'm trying to get the values by using the syntax array of the object. It will return me the output. For time being, I request everyone to maintain running notes. You know, uh, even if you are unable to cope up, then do one thing: pause the session when you are starting hands-on. Take open or rewatch the video and start working on your hands-on. Right? Yes. Yeah, that's how you can build your skills, improve your skills. So watch the videos for multiple times, guys, again and again, so that your coding skills get improved. Okay. Ah, see, what happens is in the memory. See, if I'll just give an example, my friend. See, when I keep my Python line like this, a is equals to 5. Okay, I'll execute. So in the memory, a will store the value 5. Then in the next line, I'll keep the line as a is equals to 10. Okay, when I execute a is equals to 10, no longer 5 will be present in a. A will hold 10. Okay, in the same example, you just map it to R keys, right? So when you execute with the same variable, it tries to change the location, right? Yep. Right. If no questions, we are done for the day. We'll meet on the next weekend on Monday, and we'll continue pandas, the next module. Thank you so much. But before leaving the session, if you feel these sessions are really amazing, share across multiple channels. Ask your friends to join, your relatives, whomever it might be. Uh, Ask them to join. They can learn these these topics for free. And at the end of the day, I want all of you to give your valuable feedback, and if possible suggestions as well. We'll try to enhance our sessions. Thank you so much, guys. uh, just like, share and subscribe.